So, how many of you have ever been to Singapore? Do you know Singapore? Oh, quite a few. Okay. So, Singapore is known as the little red dot, right? So, why the little red dot? Because that is our size, like this is probably about this, somewhere between Malaysia and Indonesia. So, on a map, Singapore is no more than a dot. It's a dense urban city of 40 kilometers by 30 kilometers. Now, you can translate that to miles. And it's a very vertical city, so the average apartment block, the average building there would be about 20 stories high. So it's a vertical city. But it's a population of 5.6 million people today. A lot of them are a moving population. But then Singapore has punched above its weight whenever it comes to technology, to innovation, for the size, for the age of the country. We just turned 51 in August. So some of the things that Singapore actually invented are thumb drives. Like all of us use these. In fact, I didn't realize myself until recently that this was invented in Singapore. Another interesting thing that Singapore invented was the creative sound blaster card. Anybody remember this? Like back in the Preventive days? So, great. Anybody owned a creative MP3 player back in the day? Right? So, in Singapore we say that we gave the inspiration to Steve Jobs to invent the iPod. Right? So, the only reason we didn't become the iPod was that we couldn't figure out the spinning sound, the spinning track movement. But anyway, that's Singapore's technology legacy to some extent, right? So, why smart nation? So, as I said, Singapore faces problems which any modern city faces today. And that has, in the past few years, caused us to go down this smart nation path, digitizing lives of citizens, digitizing government-to-citizen interaction. And it's fairly recent that we started to call it smart nation, started to call it IoT. I still remember about 4 years ago, I actually saw a press release from the Land Transport Authority of Singapore, who were talking about doing the next generation toll system for Singapore. And smart nation or sensors or IoT was not mentioned there. Sensors was mentioned there. We used to call it sensor networks, we used to call it machine-to-machine integration. But then in the past few years, what we've come to realize, and it's not unique to Singapore, all big cities have come to realize or capture these problems. So urban density, I mean Singapore, it's 100%, there's no countryside in Singapore. But in most of the world, the urban density is increasing in every country, right? So that means with denser living, we can have technology being used to do interesting things, right? Aging population is a massive problem. So Singapore, unfortunately, the birth rate in Singapore is not going to replace the population at the rate that it's going, which means there'll be a lot of old folks who basically need to be taken care of, and can we leverage technology to make life better for them and for everybody. The third common area is energy. So energy requirements are only going one way, right? So we ought to be smarter about using energy. So just a few trends, there are a few more about mobility. We need to make things better mobile. But then there are also quite a few things which are making the solutions to these problems possible, right? So sensors are affordable, so that's a big driver. So how many of you have seen this Texas Instruments sensor tag? So we're going to give away a few of these today. There's a train demo at the back. So we run a few positive train control demos as well as a part of the IoT solutioning. So you can check the demo out, look at the source code if you want, and a few of you will win these sensors, right? So sensors have become affordable. Batteries are very interesting. So batteries have become cheaper, which make or longer lasting, and that makes these sensors usable. And then networks, messaging, basically the integration fabric has become better, has become more usable, has become less lossy, so we can do interesting things at that end. And lastly, the insight part. So as you have information coming in, you need to make sense of that information. So big data technology, analytics technologies, Lambda architectures being used, all of those things coming together. So necessity and availability of technology is basically allowing smart city and other IoT initiatives becoming a reality. Right? So that's a big picture. Going specifically about Singapore, it's actually quite interesting, and we are fortunate that it starts at the top. So this is the Facebook page of the Prime Minister of Singapore, and he happens to be a programmer. Right, so as we started to talk about smart city, smart nation, he was in one of the founders' forum, and he basically announced that he has written a Sudoku solver. People asked for proof. He published the source code. What you don't see is that you can go and check this out. People have gone and found, okay, you use this particular binary search, had you used this, your solver would have gone faster. People have put comments in. One of the readers found a bug, so the Prime Minister acknowledged the bug, fixed the bug. So it comes from the top, right? And that helps from a culture perspective. The bureaucracy is taken care of, basically. Right? So what that means from a translation perspective. So these are some of the projects that are happening in Singapore, or were prototyped in Singapore. And you can see that they're across the board. So from water management, leak management, systems, from town planning, we've got this initiative going which is called One Map. So from the App Store you can actually download this app called One Map for Singapore, and it's a multi-layer map of various things. So from walking trails to utilities to the stuff that a city would need, and it's becoming better. More and more layers are being added. Right? Another interesting aspect, which I'll talk about later, is this next generation electronic road pricing system. Right? So what we have here is a toll gantry. So we have it in San Francisco as well. All big cities have it. Singapore has it. Singapore uses them a bit more interestingly for congestion control. So the prices are dynamic. I'll talk about that later. But there's a lot of innovation happening in this space as well. So smart transport, smart energy, smart healthcare, smart education are a few mega trends that we are working on. Okay? Now, going into transport, right? So I just want to make a point here. So what can you buy in 200,000 US dollars, right? So I did a little search, not in California, but in Oklahoma City. This beautiful house is 200,000 US dollars. Right? Now, what can you buy in Singapore for the same amount? Right, so this Ford Mustang in Singapore is 200,000 US dollars, if you're lucky. Plus road tax, plus a whole lot of other stuff on top. Right, so that's one way of us controlling our transport, our congestion, make cars expensive. Expensive to own, expensive to drive. At the same time, make public transport extremely efficient, extremely available, and also from the cars that are available on the road. And another interesting fact is, Singapore also has the highest per capita millionaire count in the world. So even though they're expensive, a lot of people own them. Right? So we still have to decongest the roads. So again, necessity being the mother of invention, we've got a few interesting things going on to optimize our transport. Right? So what are these things? So we've got buses, so the bus arrival dashboards are pretty interesting, they're getting better. So you can see which bus arriving in what time, is it disabled friendly, how many seats are available, so multiple sensors in buses are doing this job. We've also become the first country to have driverless taxis. It's actually a research program, a company, Autonomy, which is linked to MIT, and they've used Singapore as a test bed. So you can be one of the few people by invitation who can be in these taxis. So interesting feedback I saw in the newspaper where some people are saying they're spooked out, there's no driver and they're being driven around, while others are loving it, that they don't need to talk to a stranger. So it's an interesting experiment going on in one of the suburbs. Right? Another app that we have called mytransport.sg gets a lot of data from all sorts of sensors, route planning, bus stops, etc. And the ERP gantries that I mentioned, right? So this is an example, a picture of a gantry where a car goes underneath it, and depending on time of the day, you pay like $2 or $4, etc. So it kind of adjusts the traffic based on congestion. So if I don't have a meeting, I won't go to the office at 8 a.m. because this is $6. Right? So if I go at 11 a.m., it's nice, $2. So dynamic congestion-based pricing. Right? Then we also have street-side parking. We used to have like ticket systems, you punch a coupon, etc. As a part of the Smart City initiative, these are going away. Right? And I'll go into the architecture details of this a little bit. Right? So, full disclosure, this is a publicly acknowledged press release that the Land Transport Authority has issued. This system runs on Solace. So I work for Solace. I'm involved as an architect for this system, so I can give you a little bit more insight about what's going on here. Okay? So if we just look at reference architecture, trying to get a little technical now. So the way that I see it is, for any system, an IoT system as well, what you have to do is, there is a functional aspect to the system. So there are sensors out there and you capture information from the sensors. So as you capture information, this could be done over multiple protocols. Then you either store that information or you analyze that information, or you do both. Right? Once you've got the information, you make use of it. And then once you've analyzed it, you either predict stuff or you react to events. And so simplifying a functional summary of any computing, that's essentially what we do most of the time. Capture, analyze, store, react, predict, close the feedback loop. Specifically for IoT, what we find easy is when we draw the lines, so for that particular project, when we draw the lines in these three layers, and again, we didn't invent it, Cisco uses these terms all the time. There's a fog layer closer to the sensor, so between the earth where the thing is and the cloud where you want the information to go is the fog layer, so the computing there. Then we have the data center edge layer, so the cloud layer where information comes in, where you need the connection handling done, the security handling done, etc. And then further deeper into either your cloud or your data center where you want to make sense of the information. So if we understand these layers a little bit more, so you can see here from a fog perspective, the way that we like to look at things here, right? So from an architecture perspective, there's a network, the core layer, which is the network layer that can move data like TCP, IP, basically your layer-to-layer architecture. On top of that is the enterprise messaging bus fabric. So pick your favorite standards, pick your favorite technologies here. So from a fog layer perspective, you need multiple protocols often. So things like MQTT, things like REST, pick your favorite brokers. And you will need to do some throttling because a lot can happen in the fog layer and you need every message in, you leave some stuff in the fog. And then you also could do aggregation. So like in the car that we talked about, there could be multiple sensors. I just send one feed in, right? So similarly at the cloud edge layer, the problem that we handle at the message bus level is connection scaling. So like Singapore has 1.5 million vehicles, right? All of those vehicles have to connect in, send the information. So how do we deal with millions of connections? Connection scaling is a big problem, security is a problem, fan-in is a problem, burst handling is a problem. right? And then you would also do filtering and routing, right? So just slicing the pie vertically and horizontally. And as we move deeper into the core, here your problems are, okay, I have to feed this information into my big data systems, into my data lakes, right? So all my big data systems where I'll later be doing analytics, fishing in my data lakes, right? And storage, my business logic is here, so I need the ability to do throttling, to do persistence, etc. So if you just look at the architecture, right? So when you go about solving an IoT problem, at least in my experience, how I've done it, if I just take all of these areas, and if I have solutions for all of these areas, and then I use messaging and networking as a way to glue up everything, I'll be hugely successful, right? So taking care of most of the problems, and then of course the other aspects that you must not miss are device management, monitoring and management, and security, right? So we complete the IoT queue, and the bottom two parts, which is your fundamental infrastructure, we can call it the digital river. Right? So that's the data movement that is going on, and the top layer here is where your data lakes are, your analytics are, where you'll make sense of that data. Right? Make sense? Right, so spend a lot of time on this slide because now we're going to go faster. So some of the standards that the digital river will support. So networking level TCP IP, and then from an IoT perspective, MQTT being the most popular one, CoAP being talked about, then REST still very popular, AMQP upcoming, and then some so JMS standards where you have like factory floor, shop floor integration, more of server-side integration, right? And because your data river is connecting multiple applications, it freely flows into your data lakes, so kind of a side effect, so that you can do interesting things there. So applying the same concepts to our transport use cases. So I've seen this project done in a few cities. So the buses here, actually it's quite interesting. The buses, at least in one of the projects that I saw, I saw that being started as a fleet management system. So fleet management technology was acquired, sensors were put in buses, so about 20 different sensors talking to a bus-wide Wi-Fi, so very localized. So you need that gateway layer, you need the throttling, the aggregation layer in the bus. And the bus is uplinking over a 3G connection and sending REST data. So the fleet management system came with its own database, right? So it had legacy gateways and it came with its own database, and the information comes in, store. Okay, it's great. Now, when the organization went in and said, okay, now I have this data, let's do some insights over it. The fleet management vendor basically went and said, yeah, I've got a database, you can query it, right? So more and more queries, more and more database licenses. And at that point, they figured out that this doesn't really work. You need this data to stream. You need an event stream, a message bus, a real-time feed of information which has to go to multiple systems, which will grow over time. You don't know what analytic systems you're putting into tomorrow, right? So the architecture was enhanced, that the fleet management system was kind of boxed in through a legacy gateway. The newer devices or the firmware upgrades, they were brought in directly over MQTT to talk to the message bus, and then sent to multiple analytic systems, complex processing systems. And the problems that we're solving here is quite interesting. Does anybody understand what bus bunching is? I don't expect not many people take buses here, or like in Europe and Asia. So it's a pretty interesting thing. So you're waiting at a bus stop and there's no bus, right? You want to take bus 27 to work and there's no bus, you're waiting for 15 minutes. 15 minutes later, bus number 27 shows up. 30 seconds later, another bus number 27 shows up. And 10 seconds later, there's a third one, right? So it's a very irritating problem. And it's called bus bunching. You can actually Google this term, and different cities have tried to deal with this problem with algorithms. So to deal with those problems, then to calculate the average speed on a road, that's where the CEP and the sort of complex signal processing and the analytics systems were put in place. So you get a real-time feed of information and you make sense of that. And then the same systems publish the arrival times back to the bus stop displays. As the next phase, I showed you the apps there, the transport apps. So the bus arrival time information is published to the apps, to the commuters. Route planning can be done. A lot of interesting things can be done. So your core infrastructure is laid out. It's all standards-based, and you can have different systems being integrated into it. And just pay a little attention to our layers, our fog, data center edge core. As long as you've drawn your lines cleanly, your architecture will just fit in nicely. Okay. So another example for this is, so this is the project that I said, this one on Solace worked on this, so I can talk at length. So every vehicle in Singapore basically is being fed with this device. So Singapore is an island, we can control things there a bit better. So Mitsubishi Heavy Industries basically makes this device. So it has got GPS, maps, positioning, a whole bunch of sensors. So again, in the fog layer, aggregation happens here, shortening happens here, local protocols happen here. And then this sensor uplinks back, so up to 200,000 concurrent connections at any point in time, because that's the peak hour volume as we now understand on the roads. So MQTT connection handling handles here on the message bus, large bursts of data. And then this information goes deeper into the data center. So this is the DMZ zone, this is the secure zone. The characteristics of this zone is that this is shallow and wide. So a lot of connections, but each connection is sending like a message a second, so not very high throughput. The characteristics of this layer are deep and narrow. So deep and narrow. So we've got a few connections, but the overall volume of data going to the backend systems is massive. Right? So we need to deal with, from an architecture perspective, that we can adjust to all of these different characteristics. And then in the core system, what we're doing, so as I mentioned earlier, those ERP GAN trees are going away. They are being replaced with a system that you pay per use. So depending on the time of the day, depending on what road you went on, what highway you went on, completely dynamically, the pricing servers would be determining how much you need to pay, right? So it's meant to be fairer, and also from a congestion control perspective, so they know that, okay, I typically go from my suburb to the city, so to the downtown area, and in Singapore we call it CBD, Central Business District. So they can say that, okay, I typically take the Central Expressway, or today there's an accident there, it's jammed. So if I take the Central Expressway, I'll have to pay $10 in charges. But if I take the Eastern Expressway, Kallang Expressway, it'll be just $2. So they'll incent people dynamically to take different routes, right? Just because the information is coming, just that you do raw payments, but then you can also do dynamic algorithms, right? Another thing that this system is going to handle is parking. So the street side parking, which is coupon-based, and yesterday we went out for dinner and we're not sure till how long we were going to stay there. So do you punch a ticket for 2 hours or 1 hour? What if you end up coming home early? So you don't know how much you punch a ticket for, right? This is very simple. You park for whatever time, you pay for that time. Because from a sensing system standpoint, it knows where you are. So on a per second basis, easy billing. And also, if you're parked in the illegal parking, you just pay fines as simply. Right? So it's the ROI for the system is very easy. Right? So I see a few people from India. I learned driving in India. How many people here learned to drive in India? quite a fair bit, okay? So for those who've been to India, who've learned to drive in India, will relate to this, that there's no notion of safe distance in India. Right? So we really drive like bumper to bumper. But when I wrote the driving tests for Singapore, I kind of learned that, okay, at 20 kilometers per hour, you have to be 1 car length behind. 90 kilometers per hour, you have to be 5 car lengths behind. I'm sure there are data privacy issues, but what I can clearly see is, once you have this stream of data, I can just put a new analytics system here. All it does is, it does streaming queries on how many people were not sufficient car lengths behind at their given speed from the car in front, right? Get a quick report, and I'm sure my insurance company will be very interested in that data, right? So, what I'm trying to say here is really sky's the limit what you can do once you've sorted out your layers, your data capture layer from the thing, standards based, your data river layer, and then your analytics layer. Okay? So, talking a little bit more about analytics. So another interesting problem that we have in Singapore is that during peak hour in the downtown area or the CBD area, it's hard to find taxis, right? So it's very bursty. So and rumor has it that the taxi drivers are very smart. They are maximizing their returns. They put this busy thing and they are waiting on the fringes of the downtown area so that they can wait and pick up a call which gets them extra money, right? Of course, the regulators are not interested in this. So they want to make sure that cars are always available at all points in time. So how do you find where the taxis are? Where are they hiding? So extending the same architecture that we talked about. So when you look at the buses, so 5,000 buses connecting in, and there are data at rest analytics happening. So data at rest has to, which buses take longer on their routes, which routes are non-optimized, which bus lanes are not working properly. So that's what you do at rest through Hadoop, through all of those systems. And then data in motion analytics, that's the bus bunching problem. So I know that bus number 27 is going to get bunched. Can I send messages to the drivers to say that, okay, space yourself up, speed up, slow down, etc. So it's a pure lambda architecture happening, right? Streaming data and then data at rest through the same fabric. So that's the first problem that got solved. Now, from a taxis standpoint, which we saw, so these taxis, like taxi providers are not in the core system, but they have their own cloud instances. So can we have their data captured, again, through a messaging and a networking fabric, which scales elastically over MQTT and REST, and then try and do analytics with it, right? And then similarly, what we also see is like railway stations. So Wi-Fi data, cellular data, are there more passengers on the red line, more passengers on the green line, 9 a.m. on a Wednesday morning, where are the passengers, so that we can collect all of this data and then basically have a big data digital river. So the bus's data flows via this tributary into the river. The data from the taxis, which is very bursty in nature, because peak hours will have different data patterns, so it kind of comes and rains from the cloud. Our river should be able to take care of all of that extra water, less water. And then the core system here comes directly as RESTful information. So all of this transport information coming in a load balance and a throttle manner, we can put simulation systems here, with which we can say that, okay, if there was a breakdown at 9 a.m. on a Wednesday morning, which road should we introduce the buses to take care of the breakdown? Do we introduce them on the north-south side or the east-west side? Which will be better for congestion control? Which, as we build along the same architecture, the same principles, our lakes and rivers work together to solve fairly complicated problems. And so it's quite fun seeing these evolve. So switching gears a little, so smart buildings, again, we're a vertical city, so some challenges there. The challenges with the lifts, this tropical climate in Singapore, so mosquitoes are a problem. We have some mosquito-borne diseases that we manage. And then all our water is on rooftops, especially in residential blocks, so large water tankers. So their security is a big problem. Right? We want to make sure that they can't be contaminated and they're well maintained and stuff. So what is being done is sensors are being put in all sorts of these things. So like lift sensors. So there's a sad incident happened a few months ago where an old lady was taking her dog into a lift. The dog went out, the lift door closed, and the lady got injured trying to protect the dog. Right? So the question was, could the lift have prevented it? Were the sensors good enough? When later we got to know that the leash was so thin that the sensors wouldn't have detected in any way. But the point is, can there be preventive maintenance done that lifts are not faulty, enough sensors are there are sensors which are water related, humidity related, there are sensors in rooftops, in plumbing, in the electrical supplies of systems. So there's a pilot which is going on for a few of these blocks. So 85% of the residential blocks are already fiber enabled. So the data comes in from them, gets aggregated, goes into the core data center, and again, you can do whatever you want from an analytics perspective. So same architecture that we saw for the cities applies to buildings. Okay? And extending it further, we've seen this, so the Singapore Management University has this program which is a pilot for elderly care. It's called SHINE, so Smart Homes and Intelligent Neighbors to Enable Seniors. So they've taken a few sample flats of a few seniors and they've put different sensors there. So motion detection sensors. So if the senior citizen hasn't moved in a while, didn't come out of bed, like they can actually notify the neighbors, notify the caregivers instantly so that things can be taken care of. Right? So they also have installed panic buttons in homes and using some of these technologies, temperature, ambience, noise sensors, etc., to make sure that things are taken care of for the elderly. The pilot's got pretty well. So now there's talk to basically roll it out at a bigger scale. So, how's my life affected? It's got affected in pretty interesting ways. So, I was thinking through this as I prepared for the talk that, how have things changed for me? So, it's changed in a few ways. One thing is, we've got this app called Active SG, right? So, Singapore wants us to get fitter. They want me to walk more and eat less. So, basically, they've given every resident in Singapore $100 for the government for us to book sports facilities. Right? So I can book badminton courts, tennis courts, entries into gyms, etc. Out of this. So for my family, we're $400 and we are enjoying our sports like never before. Right? So that's great. But then, how do they make it even? Like, from my home to the highway, there are like 5 different new speed cameras that are available installed. How? Because God bless video analytics. We don't need radar technology anymore. So I've got 2 warning letters for overspeeding. I haven't been fined yet because I wasn't over. I was like on a 60 road, I was doing 75. But then I'm pretty sure this is what is going to pay for this. Another interesting thing I'd like to share with you, so the Health Promotion Board also has basically come up with this application which talks about, again, getting healthy. So we love to eat, we love our food in Singapore. So you can see that the first problem this app highlights to me is that not enough calories I'm consuming. So that's easy to solve. So I just look at nearby and just within 200 meters from my home, there's a ton of eateries. So easy way to solve this problem. Right? But then it also has what we call the national step challenge, and we keep on running these events out there. So this tracks like how many steps did I take on a daily basis, how does it compare with others, and it's a competition. Right? And I've tried to enroll a couple of times in this competition, failed miserably, right? So I'm more like in the bottom two bands of people who are competing here, right, in the step challenge. And the winners are doing like a crazy amount of steps, which is unbelievable, right? So some of our guys, some of my friends here walk a lot, but I still think that the winner is winning because of this. I'm quite confident that is what is going on. Is I will do the work set, and that's the winner of the step challenge. Right? So, putting this whole thing together, the Ministry of IT, so Singapore has this Ministry of IT, which actually got rebranded only last week. It's called GovTech, right? So, from FinTech to GovTech, and GovTech is, they do a lot of different programs, and they do like government data exchange, and they run the G Cloud, etc. So if you imagine, we've talked about all of these domains: smart building, smart energy, smart environment, etc. Information in their architectures is definitely acquired, but then this integration, this information is integrated using a government-wide integration fabric as well. So now the police department can have the environment data. Now the transport data can be sent to the revenue authorities. So I don't know whether they're doing this, but with the kind of systems that are going in place, it will be very easy for them to know that how frequently do you drive your Ferrari versus your Toyota, right? So interesting use cases could happen as a result of that. And we just build it out, so a government-wide fabric of a data bus, a GovTech data river, basically. And from a policy perspective, so this is also quite interesting. As I said, starts from the top, being coming from a fairly technical prime minister. What we've seen is that if you just look at the GovTech digital data river mining the network, the four key pillars, based on at least my observation, being a resident, reading the news, is there are four key pillars in building a smart city into a smart nation. Right? So GovTech, they are the techies of the government. Prime Minister's office is, of course, driving a lot of change and gets driven from top down, so things get done nicely. There is the Finance Ministry, of course, somebody's got to pay the bill. And industry participation. So they invite vendors for prototypes and do initial runs, and then after that they'll go for competitive bidding and may the best player win. And then everything else basically gets weaved into this fabric. Right? So that's what, at least from my observation, I've seen that how do you take one or two IoT projects here and there, and then you weave them into an end-to-end smart city, smart nation initiative. So, this is the last thing I'm going to talk about. So, just finishing off, we also have a pretty interesting application there for one service. And this is not unique to Singapore. I've seen this in multiple flavors. So, fix my street or fix my something. In fact, I was in the city of Warsaw, and they're doing some pretty interesting things for smart cities as well. So the program that they are running is for the visually impaired. So they won like $1 million in an innovation prize from the Michael Bloomberg Foundation, I believe. And that's like putting sensors in bus stops and indoor places and wiring everything up. And they also have such an application where you can go and take pictures of things, right? So water supply problems, road problems, littering problems, take a picture and submit it, send it, and the relevant authorities will take a look at it and they'll be tracked, basically. So I was thinking, I was not involved in this application, just that as an observer, as a user, I was thinking an interesting way to architect this, following the principle that I'm advocating. So let's say the app basically sends an MQTT or a REST message. And the REST message has a nicely qualified URL, or it could be an MQTT topic. So let's say one service, road, CBD, the central business district, downtown, as we call it here, and then my user, or I can decorate this with whatever information that I want to, right? Now, our different agencies in the government, so from the police force to the public utilities board to the land transport authority, and they are subscribing to these topics. So publishing REST or MQTT, subscribing messaging, so JMS, MQTT, pick your favorite protocol, and the messaging fabric here, that does the routing for you, that does the filtering for you. That means that the police force in their jurisdiction, so let's say in the CBD area, so one service / assault / CBD goes to them. Right? Similarly, one service / assault / Angokyo, the typo here, goes to the Angokyo Police District. So routing by event and routing by jurisdiction, leveraging publish subscribe technologies like MQTT, like even with REST here. So similarly, if you're having a road-related problem, all road-related problem goes to the headquarters of the Land Transport Authority. So it's a fairly simple, scalable architecture that you can keep on adding more and more tiles here to have new problems, new agencies onboarded, and your location will be determined by the app because the phone is location sensitive. And then, as long as you maintain a good enough taxonomy, you can have your routing taken care of. And your apps will be much simpler. You don't have to go through big business logic of orchestration, etc. And again, looking at the possibilities, we have this app coming in. So I talked about the police district, fire would go to the fire department, and as the information goes through, the Ministry of Home Affairs headquarters gets a copy of everything, so that they can actually monitor the quality of their departments. They can monitor the response time, like how many complaints were received, how quickly they were handled, how efficiently they were handled. And similarly, the GovTech guys can have all of this sent to their big data systems for longer term analytics. So they can also do interesting things with it. Right? And applying this lastly to another problem that we saw a couple of years ago in Singapore. So it's a very law-abiding, peaceful city, Singapore. So the slightest of incidents, we take them really seriously. So there was a minor riot that broke out a couple of years ago. It was basically a lot of drunk people at the same place. So I hope this doesn't happen here. So the street here. So I'm sure we're much more disciplined people. So a lot of these social media, a lot of the pictures made to the social media channels. So people are taking pictures and publishing on Facebook or Stomp, which is the citizens journalism portal in Singapore. So a lot of this information was coming in. And then of course the police was sent, they investigated it, and then once it's solved, they called in the Riot police. But had we had one service kind of an application architected like I'm proposing, basically what we would have done, we could have written an algorithm that says, if a lot of events are happening within a radius, and the types of events are basically traffic, vandalism, fire, assault, and the count is high, you don't even have to wait for the police force to go and determine what's going on. It is a riot, right? So you can trigger the riot police maybe 1 hour, 2 hours in advance and can arrest the situation in a much better manner. So that's the power of analytics coupled with a simple data capture, data movement fabric. So you couple all that together, and that's what smart city, smart nation initiatives are going to bring to us. So with that, I'd like to end the talk.